Yeah, so welcome to the continuation for our video on matrices. Now we're in the section system of linear equations in matrix form. A system of linear equations of m equations in n variables can be written as this. I will not bore you with all these algebraic representations. They are just general representations of systems of linear equations. So just take note, all the x's are variables, and then the a's are coefficients, and those coefficients of course are the ones taking positions in our matrix A, which we explained in the augmented matrix earlier. And then B, our B's are the constants on the right hand side, which we also showed in the augmented matrix earlier. Now there are two major methods we'll be considering to be able to apply matrices in solving a system of linear equations. Alright, we need to take note that we can only apply these methods when the number of equations is equal to the number of variables, or at most number of variables must be less than the number of equations, right? Less or equal to the number of equations, then these methods will work, right? So this matrix X, of course, X are the variables, those are the things we are solving for, those are the solutions we want to get. We want to get values for those variables, so tag them as a matrix X. Let's see. So the first method is the inverse method. The bottom line of the inverse method is that once we can get our system to be in this form, ax equals b, and we have verified that the determinant of our matrix A is not 0, then we can get this matrix X, which is the matrix containing the variables, the unknowns, by this is the bottom line, A inverse B. A inverse B, once you can solve A inverse B, you get X. And A inverse is a special type of matrix relating to A, right, which we will discuss. And then determinant of A too, we'll see all that now. Solve the system using the inverse method. We have this system, 2x plus 3y equals 7, x minus y equals 1. So we transform it into a x b format. Our A will contain coefficients 2, 3, 1, and minus 1. And then our X matrix will contain the variables. Our variables in this case is X and Y, which is what we are looking for at the end of the day. Then our matrix B contains the constants on the right hand side, 7, 1, right? So we said X will be equal to A inverse B at the end of the day. So we need A inverse, right, first of all. But to obtain A inverse, we need the determinant of A. This is the formula for A inverse. A inverse is 1 over the determinant of A, and then for a 2 by 2 matrix, you switch the values on your main diagonal, right? As you can see, -1 is showing up here, and then 2 is now down. Then the values left, which is 1 and 3, we multiply them by -1. That's the standard for getting A inverse for a 2 by 2 matrix. For 3 by 3 matrix is different, and it's a very long procedure. We'll be skipping that for your level. We'll just do 2 by 2 for inverse method. 3 by 3 we use the second method, which is Crammer's rule. So determinant, now how do we find determinant? Determinant is simply for 2 by 2, you multiply the elements on the principal diagonal and subtract from the product of the elements on the other diagonal. So that will be 2 times -1 minus 3 times 1. That gives us -5 at the end of the day. You have to be very careful with signs. And as you can see, -5 is not 0. So it implies that our matrix A is invertible, right? And since A is invertible, it means that A can have an inverse. If your determinant is 0, this fraction becomes undefined, and that's why I would say matrix A therefore is non-invertible in that case. So we need determinant of A to be non-zero. So we'll put everything we have here. Our A inverse is now 1 over -5 times this, and we have this at the end of the day as our A inverse. So for X now, which we said is A inverse B, we'll take our matrix A inverse, we'll multiply it by matrix B. And yes, they are conformable. Matrix A inverse is 2 by 2. Matrix B inverse is 2 by 1. So the number of columns in A inverse is 2, and the number of rows in B is 2. So they are conformable. So we'll get a result of a 2 by 1 matrix, which is this our X at the end of the day. As you can see, it's also 2 by 1. So A inverse times B will give us our X and Y straight up. So how do we do our multiplication? Take row 1 in the first matrix against column 1 in the second matrix. So that's 1 over 5 times 7 plus 3 over 5 times 1. We'll get our row 1 column 1, which is X, and then 1 over 5 times 7, that's row 2 against column 1, will be 1 over 5 times 7 minus 2 over 5 times 1. That will give us Y. That will give us row 2 column 1 in the product, which is this Y at the end of the day. So when we solve all that, X gives us 2, Y gives us 1, and so X is 2, Y is 1. If you sub these values, X equals 2 and Y equals 1, into the system we're given, you see that you get the answer on the right hand side, 7. So the system will be balanced. We have a 3 by 3 matrix here with inverse method for the scope of this class. We'll skip that, and to make our video short, we'll go straight to 3 by 3 with Crammer's rule. So what does Crammer's rule say? Crammer's rule is a method for solving a system of n linear equations in n variables when the coefficient matrix A is square and the determinant is not 0, right? So Crammer's rule is strictly for a system where the number of equations equals number of variables. So once we can transform our system to the ax equals b format, then our first variable is gotten this way: determinant of a1 over determinant of a, second variable this way, third variable this way. So what's new here is all this determinant of a1, determinant of a2, all right, which we'll see how to obtain. Let's go straight to the example for 3 by 3. 2 by 2 is quite easy. If you can do 3 by 3, you'll be able to do 2 by 2. So solve the system using Crammer's rule. We have x plus 2y minus z equals 3. 3x plus y plus z equals 1. X minus y plus 2z equals 2. Transforming to ax equals b, our matrix A carries the coefficients of our variables, right? We all know how to do that by now. Matrix X in this case will be a column matrix, which is x, y, z. Our variables are x, y, z, and that verifies the fact that we have 3 equations and 3 unknowns, x, y, z. And then our matrix B, the constants on the right hand side, as 3, 1, 2. Now, first we need the determinant of A. That will be at our denominator when we are working out with Crammer's rule. Determinant of A for a 3 by 3 matrix will take the element on the first row, first column, right? Since it's on the first row and the first column, we eliminate the first column, the first row and first column. We'll be left with 1. So follow my cursor now. 1, 1, minus 1 and 2. We'll treat that as a 2 by 2, which we already know how to do. We'll find the determinant of that. That will be 1 times 2 minus 1 times minus 1. Right? That's what we have here. That gives us 3. Now we'll move to element on row 1, column 2. That's this 2. So we'll delete row 1, we'll delete column 2. We'll be left with 3, 1, 1, 2. Right? We'll treat that as a 2 by 2. That will be determinant of that 2 by 2 will be 3 times 2 minus 1 times 1. That gives us 5. We move to this last column, right? That's element on row 1, column 3. This minus 1. We'll delete row 1, we'll delete column 3. We'll be left with 3, 1, 1, minus 1. We'll treat that as a 2 by 2 and find the determinant. That gives us minus 4, right? Now, lastly, we'll sum those values up. This 3, 5, and minus 4, but then we'll alternate signs. The first one remains the way it is, but the next one will attach minus 1 to it. multiply by minus 1. So that will be 3 minus 5 plus, the next one will be plus. So it goes plus minus plus. Alright, so that's 3 minus 5 plus minus 4, and then we'll multiply them by those numbers that were on those places that determined where we deleted the entries 1, 2, and minus 1. You can see the alternation of the signs here clearly, minus and then plus. So we have 1 times, we got 3 for this one. 1 times 3 remains 3. Then minus 2 times 5, and then plus minus 1 times minus 4. So we have 3 minus 10 plus 4. At the end of the day, our determinant for our 3 by 3 is minus 3. Then we find x by replacing the first column of A with B. Right? So x is our first unknown, first variable. Y is the second variable. Z is the third variable. X will work hand in hand with the matrix A1. How do we get matrix A1? A1 is gotten by taking our matrix B and fixing it in column 1, and that goes hand in hand with variable 1. Variable 1 is x, right? It goes, we pick B and replace our column 1 in matrix A. This 1 3 1 will be replaced with 3 1 2 from B. Every other element remains intact. Then this new matrix A1 now will find the determinant. Right, the same way, we'll take 3 times the determinant of this 2 by 2. When we eliminate row 1 and column 1, we left with 1 1 minus 1 2, right? Then minus 2 is on row 1 column 2. We delete row 1, delete column 2, we have 1 2 2 2. 1 1 2 2, right? Then plus minus 1 is on row 1 column 3. We delete row 1, delete column 3, we are left with 1 1 2 minus 1, 1 1 2 minus 1. We'll find those determinants of those 2 by 2, multiply by the respective entries, and we have determinant of A1. Determinant of A1 is 12. We said it works hand in hand with our first variable, which is x. So x now is gotten as determinant of A1 over determinant of A. We got determinant of A earlier to be minus 3, if you remember. That's it there. So x now will be 12 over minus 3. That is determinant of A1 over determinant of A, and that gives us minus 4. X is minus 4. A2, now we work with our second variable, which is y, right? Variable 2 is y. It works with A2. A2 now will take B. Remember, B is matrix that has entries 3 1 2. A2 will take matrix B and fix in the second column of matrix A. If we fix B in the second column of matrix A, it means we're eliminating 2 1 minus 1. Right, so 3 1 2 will replace all that, and that new matrix is matrix A2. We'll find the determinant, same procedure. We'll get minus 20. So y now, which is the second variable, will be determinant of A2 over determinant of A as minus 20 over 3, which is 20 over 3. Minus cancels out minus. So we have x, we have y now. For z, which is our variable 3, we work with matrix A3, and that brings B into our third column of A, right? Third variable forms A3, bringing B into third column of A. Every other element in A remains intact. Find the determinant of A3. Same procedure. Find the determinant of A3, we have minus 19, and Z will be determinant of A3 over determinant of A. That gives us 19 over 3 at the end of it. So x is minus 4, y is 20 over 3, z is 19 over 3. So thank you for watching. We have summary of the whole video. You can go through all that on your own, and we'll have 10 exercises for you to practice. So you can pause the screen to take snapshot of the exercises. Thank you. Goodbye.